In exercise 1.3, we take a look at histograms. There are various types of histograms, but the main uh, point of emphasis I want you guys to know about histograms is they are solely for numerical data. Okay, they are for numerical data. In the case of continuous data, we do have histograms for continuous data, and they look like the following. What you'll notice is the first difference between histograms and bar charts is histograms don't have any gaps between each bar. The other thing is with continuous data, it's impossible to write a bar or have a bar for each and every number that has a decimal. So what we do is we group, I guess, things together. Okay, so group numbers together. For example, if you are between the ages of 0 and 10, okay, you would fall under this far left bar. All right, so if you were 5, 6, 7, 7.4 years old, 8.4 years old, whatever it might be, you would all fall under this section of the histogram. If you're between 10 and 20, for example, 10.3 years old, 10.7 years old, 15.6 years old, you would fall under this second section of the histogram. All right. And what you notice is it's hard to be exact with these continuous histograms. We don't know their exact ages, but we do know in this survey, whatever it might be, we have 5 people between the ages of 0 and 10. What specific age? We don't know. That's one of the downsides of these continuous histograms. But we really have no other choices because, you know, if we have someone that's 5.3 years old, someone that's 5.5 years old, someone that's 5.7 years old, it's not feasible for us to give them each a tiny little bar. Otherwise, our histogram would go on sideways forever. So that's why we group them together to give an overview of the amount of people in each age bracket in this example. You might also get ungrouped discrete data histograms, which have, I guess, discrete numbers at the bottom. But what you notice is with the grouped, okay, 0, 10, 20, they are on the line, okay, the vertical line of each bar, meaning 0 to 10 would fall under this middle segment. If we have discrete data where we know the exact number of people that's been surveyed, okay, we put those discrete numbers now in the middle because it's definitive. It's not 1.1, 1.2, 1.3, and each has a little bar. Okay, if you are in this far left bar or column, there is only one number of people, okay, that were in this example in the house of this particular suburban block. All right, there's no 1.1, 1.2, 1.3 number of people in that house because, as we know, people can only be whole numbers. So there's no need to have the numbers on each, I guess, vertical line of the histogram. All right, so see the difference? Hopefully you see it by now. The next part is we start taking a look at symmetry and skewed distributions. This is how we sort of describe the grouping or I guess the distribution frequency of whatever we surveyed based on the histograms display. If we have the middle being the tallest bar or column, and then everything around the middle is evenly spread on either side, we can say this is symmetric. Let me just highlight this. We can say this is symmetric. If we have multiple peaks, like twin towers, we can say this is double peaked. Whether or not it's symmetric depends on the other bars. All right. But if they're evenly apart like this, and there's two pairs of clear-cut peaks, or two I guess evenly barred peaks, then you can say it's double peaked. Down below here, we have two types of skews. What you notice is the positively skewed histogram is actually leaning towards 0 or running away from the positive. So what you want to think of is positive skew, okay, runs away from the positive. And what you notice with negative skew is it actually runs away to the negative. Like most of the data points are tilted to the positive side. Confusing? I know, right? So this is, oh, that's a real straight line. That's running away from negative. Once you realize it's running away from what it's stating, so if it's negatively skewed, it's running away from the negative, that might make it a little bit easier to identify. Remember, further maths, you'll have to bring in your notes. So have this located in a safe place so you can always come back to. Outliers, they are just segments of or sections of the histogram or bar chart. That's, just histograms. That's apart from the main bars or columns. Medians here, well, whenever we're dealing with a continuous histogram, 0, 20, 40, 60, where the numbers are on the vertical lines, we can only roughly estimate where the middle is. Okay, so if we say there's 100 here, there's roughly 125 there, 200, so you add them all together, 100, 225, 425, 500, 550. What you then have to do is just approximate and go, well, what's half of 550? Half of 550 is about 275. So if this is 100 and this is another 125, this would mean there's 225. So 275 would somewhere be in this middle column of the histogram. So we can just roughly draw a line and say, well, it's closer to probably 40 than it is to 60 because we're already at 225 in the first two columns. And so 50 more would mean that it's closer to 40 rather than 60 because we have 200 responses in this column. So that's why the estimate was roughly 45. Range, on the other hand, is a lot easier to see, especially with discrete histograms. Okay, the range is always the largest value, take away the smallest value. Here, the largest is 7, smallest is 1. Just in case you forget in an exam, I'll try and color code this for you. All right, so the largest value is 7. Okay, the smallest value is 1. Oop. Which would give us the answer of 6. And that's all for exercise 1.3. Best of luck. Let me know if you have any questions.